everyone, it's Miss Wade. I'm here to talk more about some log properties that we didn't get to in the last video. So we have 3 more log properties we're going to talk about today. So the first one, these are kind of little unique properties. This is the first one. So log base b of b to the y is really just y. And if you recall, writing things in exponential form versus logarithmic form, if you were to take b to the y equals this, you notice you get an equality statement. So that's why that's true. And then here's another one. So if I have b to the log base b of x, that is essentially just x. Okay, so these pretty much cancel and you just get that. And if you were to write this exponential in logarithmic form, you would notice that you get b to this equals that. So that is it in logarithmic form, which also makes an equality statement. So these two properties, I showed you why they're true on the right by showing that you get something that's equal. So let's practice with these. So we're going to evaluate. So here's the first one, log base 3 of 3 to the 5th power. So if you notice, this one is very similar to the first log property up here. So when these two numbers are the same, then the answer is just this exponent up here. So log base 3 of 3 to the 5th is just 5, if you use that rule. Okay, here's the other one. 6 raised to the power of log base 6 of 10. Because these numbers are the same, it cancels and you just get 10. Now these are pretty simple, but they can get a little bit trickier. So here's one that gets a little bit trickier, but I think you guys can handle it. So these properties only work when this number is the same as this number. Okay? Right now, it's not the same. But think about how you can rewrite 8 to have a base 2. So you guys know that 8 is really the same thing as 2 cubed. So I'm going to rewrite this as 2 cubed. Okay? And now I have the same base. So you think, okay, well the answer's got to be 5. Sort of, except what about this rogue 3 here in front? You got to do something with him. Well, now you're going to use the properties we talked about in the last video. So this is the power rule or power property. So when it's in front, it really means that it's the same thing as 5 cubed. So now these are the same and you just get 5 cubed, which is your answer. And then obviously, it's probably a good idea to write it as 125. So that's a little tricky. Not too bad. Why don't you guys try this one? Same idea. And then we'll increase the difficulty in a minute. So go ahead and pause the video. Try that. Those are not the same. So I'm going to rewrite 9 as 3 squared. Bring this up here because now those guys are the same. So those pretty much go away and you just have 2 squared, which is 4. Okay? Now, let me give you one more. This one's a little bit harder. This uses some of the things that we did the other day. Also. Okay. So you'll want to go ahead and try to rewrite this so that way you can simplify. So go ahead and pause your video. Try it. Come back and join. if you recall, now that you've tried this, hopefully you guys got this right. So 125 is 5 cubed. It's inside a fourth root, which means it's 5 to the 3/4. But it's in the denominator, which means you move it to the top and make it negative. So now these are the same, so you just get negative 3/4. And you can write x equals or just negative 3/4. It doesn't really matter. That's what it evaluates to. Okay, now sometimes you can't do this. Sometimes it's kind of hard. If I gave you something like this, there's no way you could write 7 as a power of 4. It just can't happen. So that brings us to our next rule, which is called the change of base. And you use this whenever you can't rewrite it. It's a nice little handy thing. So log A of B, which means you can't rewrite B to have a common log with that. So the way we do it is we take the log of the top, or of this part, divided by the log of that part. And in this case, C is 10. So basically what we're doing here is we're rewriting using common logs. And common logs are base 10. Okay? So you should make sure to write this down. This is a handy little trick. And we're going to apply this to number 6 because we can't rewrite it using those other rules, or properties rather. So in this case, I'm going to rewrite it as log of 7 over log 4. And these are basically log base 10s. Okay, and you can use your calculator to figure this out. You just punch the log button and then the number, and that gives you the answer. So on my calculator, I would just press log 7 and I would get 0.84509, etc., etc. And it doesn't really matter how you round it. I usually like tenths or hundredths. So when you're all done with that on your calculator, you would get 1.4. Okay? So here's another one like that using the change of base. Log base 3 of 16. There is no way I can write 16 as a power with the base 3. It just can't happen. So you're going to use change of base. So you're going to do log of 16 over log of 3. Hopefully you paused this and tried it on your own. It's good to practice. Doesn't matter how many decimals. So there's that. All right, so we talked about 3 properties so far in this video. These first 2 where you can rewrite it with the same base, or when you can't rewrite it with the same base, you do the change of base. Now sometimes you don't have calculators and you want to figure out logs, and so there's a lot of problems on the SAT and other tests where they do this kind of stuff where they tell you what certain log values are. And then you have to apply all the properties. So let's try that. That's going to be the last thing we go over in this video. So let's say log 2 is approximately 0.301. So whenever you're not allowed to use a calculator, like on part of your test, hint, hint, you will have problems like this, where we're checking to make sure you know how to use the properties and you're not just plugging a bunch of stuff in your calculator. So here's the givens, those right there, and you're going to use that to evaluate different logs. So we're going to use these same 3 for the next 4 examples we're going to do. So if I want to evaluate log 15, notice 15 is not up here at all. What you do have, whoa, rogue highlighter, we have a 2, a 3, and a 5. So you have to think, okay, how can I make 15 out of these numbers? Well, 3 times 5, hello, that's easy, right? So you're going to rewrite this using the properties we learned in the last video of 15 as 3 times 5. And when you have log of a product, you're going to use the product property that we learned, and it's just log of 3 plus log of 5. And notice, log of 3 we know what it is. And log of 5, we know what it is. So we're just going to substitute those decimals. You guys learned decimals in what, like 5th grade or something? You should be able to add those without a calculator. And you get approximately 1.761. We don't really care how you round, so there it is. So you don't have to have a calculator to do these, which is nice because we like to give you no calculator parts to test to make sure you know what you're doing. So why don't you pause your video right now and try that one, okay? How can you make 30 out of a 2, a 3, and a 5? So pause and try. Okay, so 30 is 10 times 3, and 10 is 5 times 2. Well, I have a 3, I have a 2, and I have a 5. Perfect. So it's basically log of 2 times 3 times 5, which is a product. So you're going to split this up into log of 2 plus log 3 plus log 5. And just a friendly reminder, these are all log base 10. Common logs that you can do on your calculator, but we gave you decimals instead. So when you add those all together, you should get this. Okay, just add them up on your calculator. 0.301 plus 771 plus 0.6990. So that's how I got 1.4771. Okay. I would like you guys to please pause the video and try 3 and 4. So the last 2 in the video, you're in the home stretch. I know you guys got lots of homework tonight, so thank you for watching these videos. All right, do those 2. Pause the video, try them, and then come back and check your answers, please. Welcome back. Hopefully you guys actually followed directions and paused. So 9 is, you can write it as 3 squared, or you can write it as 3 times 3. If you do this, you're using the power rule. This one, you're using the product rule or property, whatever. Doesn't really make a difference. It's the same thing. You will get the same answer. So when you add that one up, you have 0.4771 plus 0.4771, which is 0.9542. And then last but not least, this one, we're going to split it up. Because it's division, you're going to rewrite it as subtraction, right? So it's 0.6990, whoops, I wrote that wrong, minus 0.4771. And this one, you know, subtraction, 5th grade was a long time ago. I'm just going to use my calculator, but we would give you nice numbers if we had this on a no calculator test, so it wouldn't be so brain busting for you. So thank you for watching. That's the end of this video.